Hi, guys and girls. Sorry I'm not there with you today. I don't feel very well, but I still want to teach you, so I'm making this video for you. This is for Investigation 2.2 of our Connected Math Variables and Patterns. We are talking about the 5 college students on their bike tour. So far, we've talked about some of the things that they've had to think about, like where should they take the tour? How far do we think people are going to travel in one day? They've set up their route. We've talked about renting bikes, and they decided where they want to rent the bikes from, how many bikes they should rent. Now we're trying to figure out a price. So they want the price to be low enough that people will come and take the tour, but they don't want it to be too low because they want to be able to make some money off of it. They also don't want the tour price to be too high or nobody will come and take the tour. So we have to kind of try to find that happy medium. So you'll see on your worksheet that there is a table, which is also on this book page. And this is what happens. The 5 college students want the price to be low enough to attract customers, high enough so money collected makes an income. And they're hoping that if they go out and survey people, they can get a good idea of what to charge. So they conduct this survey. They go out and they ask people, would you pay $150 to take the tour? And 76 people say yes. They ask those same 76 people, would you pay $200 to take the tour? And 74 of them still say yes. They ask those same 74 people, would you pay $250 to take the tour? And 71 of them say yes. So they keep going with their table and they keep increasing the price. And every time they increase the price, a few more people are less willing to pay. And you see later in the table, they ask, would you pay $500? And only 26 people say yes. What about $600? Nobody's willing to pay that much. So what I would like you to do is do like a think, pair, share, or a turn and talk, as we've been calling it. Think to yourself, what would be a good price for the tour operators to charge? And then turn and talk to the person next to you. So nobody needs to get up out of their seats, really. And we can pause the video for a minute. What do you think would be a good price for the tour operators to charge? Okay, now that you've had some time to discuss, I would like you to add that to the top of your worksheet, what you think a good price would be and why. And then I'm going to turn the camera over to my worksheet because I also want you to add a few notes. Okay. And I apologize for the poor quality of our camera here. I did not plan on being home. Do not have a webcam at home, so we're stuck with my little Chromebook camera here. And I think I can make the screen a little bit larger for us. That's about as good as we're going to get. Okay, so at the top of your paper, you have your prediction. What do you think the tour operators should charge and why? You have your table, and then I'm going to have you add down at the bottom some notes. If you can write down variables, and then independent, location in the table, location on the graph. So I would like you to figure out, in the table, you have 2 variables, total price and number of customers. I want you to figure out which one is the independent variable and write down where is that located in the table, and then where is that going to go on the graph. So is your independent variable your total price or your number of customers? If it's total price, it's going to be on the left side of the table. If it's number of customers, it's going to be on the right. And then tell me on the graph, does that go on your x-axis or your y-axis? And then I want you to do the same thing with your dependent variable. I need you to tell me which one of those two is your dependent variable. Is it total price or number of customers? Where is it in your table? So is it on the left, total price, or on the right, number of customers? And then on the graph, is it going to go on your x-axis or your y-axis? Okay. Then what I would like you to do is take some time with somebody who is next to you. So again, we're not getting up out of our seats. We have to be careful that we're social distancing with COVID. And I would like you to work with that person next to you and complete your graph. So you're labeling your x-axis and your y-axis with total price or number of customers. You're giving your graph a title and you're numbering your scale. Remember, with your scale, you're skip counting by 2s, by 5s, by 10s, by 3s, by 20s, by 50s, but something that you skip count by. So I should not see you using number of customers as the numbers in your graph. Do not label your graph 0, 14, 26, 38, 49. That is not a pattern you can skip count by. So pause here. Take some time to work on your graph and then come back when it looks like most of you are ready, and we'll discuss what your finished product should look like. Okay. Now that you're back, you should have for your independent variable your price. The total price is your independent variable. It comes first in the table on the left-hand side and should go across your x-axis. Your dependent variable depends on your independent variable. So if I asked you how many customers are going to take the tour, it depends on the price. The price is just a list of numbers. Okay? How many people are going to take the tour for $550? Now I can answer that question because I have a higher price, I have a lower number of customers. If I have a lower price, I have a higher number of customers, and we're going to see that in the graph. So dependent variable, I have number of customers. The number of customers depends on the price. It's on the right-hand side of the table and on the y-axis. So when I go to look at my graph, total price across the x-axis, number of customers on the y-axis, my title, price customers would pay, I got that from the table. And then also you should see a pattern where it starts out at a really, really high number, okay? I have a high number of customers that would pay a low price. As the price continues to get higher, the number of customers drop. All right? And then to answer your question, how much do you think that they should charge? I went ahead and did something for you because I knew some of you would be wondering if you were correct or not in your prediction. Not that it really matters because it's all for fun. But if you actually wanted to figure out how much the income is, you could take the total price times the number of customers. So I went ahead and did that for you. If you take a look at this and you take the total price times the number of customers, this is your income along the side here, showing how much money they would make. Now, this is not their profit. This is just their income because we don't know how much money they're spending to set this up yet. But you can see here that the income increases. And at about $350, they're making their most money right now, their most income. So $350 seems like it would be the best. Although $300 or $400 also gets them something close to it. Okay? And then just a side note here. If you made an oopsie and you put number of customers and total price on the wrong axes, your graph would still look similar to what we did, but it would totally show that it would maybe not decline as quickly as our graph did, maybe fall off the edge of the graph. You can see I wrote this as incorrect. If you accidentally switched around the dependent and independent variable. So we're going to talk more about what happens if you accidentally put dependent and independent variable on the wrong pieces of the graph, but I just wanted to show you the difference between those two. Okay. All right. So thank you for watching. I miss all of you. Go ahead and put this paper in the investigation section of your binder. You will be watching another follow-up video, and hopefully I will be back with you again sometime soon. Until then, everybody have a good day and a good week.